All right, good morning, everyone. Did you have a good weekend? Yeah. So how did the Zoom go for y'all last week? Were y'all okay with it? Yeah. Zoom, right? You like the in-person better? Yeah, I came to hate the Zoom, but I actually didn't mind it too much last week. All right, so we have an exam on Thursday, yes? Y'all got the review I sent out? Yes? Y'all got the review? Yeah? Okay. So I'm going to continue today with more material, and then if you stop me 10, 15 minutes before the end of the class, we'll talk a little bit about the exam, all right? But we're not going to spend the whole day reviewing. All right, questions? Any questions over homework or anything? There were a few problems out of that section that I asked you to look at. Any issues with those? We're in chapter 2. All right.
Regarding those notes,
Mm-hmm.
the Wolfram notes.
Yes. You can't open them?
No, there's a certain file type or something.
So I have the notes in PDF, right, that you can open?
Oh, okay. They're
right?
slightly different than the ones you have in class.
That's right. Okay, so but the ones that I don't want to get in there. In the files, there's two sets of notes. One you can open, one you cannot. Is that what you're saying? Yes? Okay, if you want to open up the ones just like I have in class, you have to download what's called the Wolfram Player. So just go to Google and type in Wolfram Player. And you can download the software to your computer, and then you can take those files off Canvas and you'll be able to open them. It's free. I think you have to put an email address in, but okay. All right, so we started talking about the derivative, right? Last time, special limit. And we didn't get through this whole thing, right? There's a lot of notes in here. So what I'd like to do is continue and kind of remind you what our main takeaway from last class was. And that is, if you have some function f, and you were to pick some point A, our goal is to see if we can find two things. First, can we find the line that's tangent to that? That's called your tangent line, right? One, can we find the slope? Find its slope, right? That would be the first question. Second question, can we find its equation? Right? That's the main kind of takeaway from last class. And the way we did it, the way we actually built this thing up, is we said, all right, what we'll do is we'll pick some second point. We'll pick an x value. We called it x here. And then we created this secant line. And then what we did is we moved this x towards the a until they were essentially on top of one another. And to do that, we had to take a limit, right? And then once we do that limit actually answers the first question. So now I'm going to come over here and tell you the answer. Can we find the slope? Yes, right? How do we do it? We say that the slope of that tangent line will be equal to the limit as x approaches a of f of x minus f of a over x minus a. That's the slope of the tangent line, so long as we can calculate that limit, right? And anytime we do this, right, anytime we do this for any function, when we set up this limit, we're always going to have a 0 over 0, which means we're going to have to do some sort of algebra or trick, and then we get it, hopefully, to work out. That's what your homework was about, right? Those homework problems? And then, can we find its equation? Yes. How do we do that? Well, what we do is we use the point slope formula for a line. We use this formula from college algebra. And the big key is that instead of using just m, some arbitrary m, we actually use this answer we get from that limit. That goes in here. And then the only other thing that we need is a point. And that point is always that point right there, whatever the x and y coordinate is of that point. All right? Does that make sense, like big picture wise? Any questions? Okay, should we just do an example to warm up or do another one of these just because it's been a little while? All right, so let's do a specific example. How about one off of the review? You want to do one off the review? Anyone happen to print it out or have it in front of you? Because I can look it up, but no? Yeah, I probably can get to it faster here. Let me see. See where I put it. Exam 1 review. There we go. So this is the review. Let's get to the bottom of this thing. That one right there. Okay. Let's do that one. Find the equation of the line which is tangent, right? So we want to go all the way to the point where we have an equation of the line that's tangent to that curve at some point 1, 4, all right? So the first thing I'm going to do is figure out what? The slope of the tangent line, right? So let me start by calculating the slope of this tangent line. And to do that, I'm going to take the limit. Let me write the formula down first. X approaches a, f of x minus f of a over x minus a. All right, that's my formula. And for us here, this is an important thing to understand. What is a? The x value for the point that we're looking at, right? And what's our x value here? 1, right? So this right here is a, right? That's a. I give you, in that point, I'm actually giving you what a is. Not only am I giving you a, do you also agree that 4 should be what I get when I plug 1 into the function? Right? If that point lives on that graph, then when I plug 1 in here, let's check it. 5 times 1 is 5, plus 3 is 8. Divide that by 1 plus 1 is 2. 8 divided by 2 is 4. Right? So that point lives on the graph. So this point, this number right here, 4, is actually f of a. And that's very helpful because now when I write this limit out, I can do limit x approaches 1. Okay, let's start putting these pieces together. What is f of x for us here in this problem? It's this whole thing, right? It's the entire thing as a fraction. So I'm going to write it. That's f of x, 5, x plus 3 over x plus 1. And then I'm going to subtract from that. So subtract f of a, right? And what's f of a? 4. We just said that, right? F of a was that right there. So that's going to be 4. And then I divide the whole thing by x minus a, so that's just x minus 1. There it is. That's the thing that we need to find the limit of. If you were to check right now and do direct substitution, you would get 0 over 0, which means we need to do some algebra, do some trick, right? Okay, any questions up to this point? Let me say something else. Another way that this problem could have been presented to you, right, on a test is I could have said, find the equation of the line which is tangent to this curve at, and I just say x equals 1, and not give you the point. If I give you this, then I've actually withheld some information from you, right? I didn't give you the 4, which means that you would have to get that 4 yourself, right? But it's not that hard to get the 4 because you just plug 1 into this, right, and you get 4. So just be aware of that. The problem could come, I either give you the point, which is everything you need, or I give you just the x value, which means you have to go get the f of a. All right, what do you think? What should we try here? We see a complex fraction, right? Fractions with fractions. So what was the kind of rule of thumb for that? Common denominator, right? Let's go to the numerator right here. Let's try and put these together into one fraction. Let's do that. So I'm going to look at this 4 right here as a 4 over 1, right? That's really what 4 is. And then I'm going to write 5x plus 3, let me see here, minus, okay, and when I look at these denominators, I have a 1 and then this one right here. So the common denominator is going to be x plus 1. So what I need to do is I need to take this 4 over 1, and I need to multiply it by x plus 1 on the top, x plus 1 on the bottom. That way they both have an x plus 1 on the bottom, right? Hey, could I have done this? Could I have done, instead of doing this blue part here and multiplying it and getting an x plus 1 on the bottom, could I have just done this, I don't know, just do like an x on the top and bottom and add them? And that way on the bottom I get 1 plus x. Could I have done that? No, right? Why? Well, this is 1, right? That's a 1. If I take 4 and add 1, do I still have 4? No, right? If I take 4 and multiply by 1, do I still have 4? Yes. So this right here doesn't change the problem. It's still a 4. This changes. So this is like illegal algebra. You're not allowed to do this, all right? Plus, when you add fractions, you don't just add straight across. So I've just seen this mistake before, so I just want to point it out. Don't do this. Always multiply by the common denominator. All right, all of that over x minus 1. And now let's distribute the negative 4 through here. And so my next line will be limit x approaches 1. All right, we still have the 5x plus 3 over x plus 1. And then minus, when I distribute that 4 through the top, I get 4x plus 4. And then over the x plus 1. Then all of this over x minus 1. They both have the same denominator now, right? So I can put them together. So when I put these together, you have to be real careful, right? This negative sign actually goes through to both of those, right? So it changes the signs on both of those terms. So my next line should be 5x plus 3 minus 4x minus 4 all over x plus 1. The entire thing still over x minus 1. And what I'm really hoping for here is that when I clean this up, that somehow this x minus 1 is going to cancel. Does it? Well, what is all of this together? X minus 1, right? So I have limit x goes to 1. I have an x minus 1 on top over the x plus 1, but then all of that's over x minus 1, right? And to really see what's happening here, just look at that bottom as a fraction. And you have a fraction divided by a fraction, right? So you can flip it and multiply. So if I flip this, bring it up, it's 1 over x minus 1 like that. Get rid of it here, because you flipped it up. You're multiplying. These cancel. And then let me see if I can squeeze this in here. Limit x approaches 1. And then the only thing left is what? Be careful here. What's left? We canceled these, didn't we? 1 over x plus 1, right? Not x plus 1, 1 over x plus 1 is left. So 1 over x plus 1. And now I can take that limit. I just let x go to 1 now. And I get 1 plus 1 on the bottom, that's 2. That's a half, right? There you go. It's a half. So if I were to graph this, which we will, I'm going to go to Desmos, I'm going to graph this in a second. If we graph it, and we go to this point 1, 4 on the graph, we should expect to see our tangent line has a slope of 1/2, right? Now that doesn't give us the equation of the line though, right? That just gives us the slope of the line. So now I need the equation. And on exams, what I have happened quite a few times from students is that they'll do that, they'll box the answer, they'll move on to the next question. And so I take off because I'm asking for the equation of the line, right? I'm not asking for the slope. So you're not done. Now, if you did that on the test, I wouldn't take off like full. Like if you got to the 1/2, it wouldn't be like it's all wrong, but I would take points off because you haven't done what I asked you to do. All right, so for the equation, use that formula, y minus y1 equals the slope of the tangent line x minus x1, like that. This is y take away 4 equals the slope we just got, 1/2, and then x minus 1. So just replacing x1 with 1, y1 with 4, and we've got our equation. And that on the exam would be completely okay with me. Just box that up. Of course, you could distribute the half through and solve for y and do all that, but that's good enough because that is the equation of the tangent line. So I'm gonna go graph this, maybe. Let's see. We have y equals 5x, what was it, minus 3? Was it minus 3? Over x minus, I think it might have been plus 3, hold on. Plus 3 over x plus 1. And I'm also going to plot the point 1, 4. All right. So there's the graph, right? There's the graph. And we're looking at the point 1, 4 right there, trying to find the equation of that tangent line. And we said it was y minus 4 equals 1/2, I'm going to put 0.5, and then x minus 1. There it is. We did it, right? We found the equation of that tangent line. Yes, ma'am?
The equation we have on the board, is that the same thing as the y minus f of a equals the limit?
Yeah, yes, Yeah, but instead of writing this thing as a limit, I just wrote right? Because we said the slope of tangent line is that limit. So instead of plugging that whole limit in there, just plug the number that you get into that. Other questions? All right. I believe that was the last question on the review. Yeah. No, oops. Oh, that was a bonus. Okay. So that is the extent of what I would feel you should be able to do for that test in terms of equations of tangent lines. Yes, ma'am?
I just wanted to confirm, the formulas are not going to, that definitely weren't going to have to memorize, not being able to bring to the test.
Yeah, so for this test, right, I said the formula for that slope of tangent line, you need to get it burned in. Now, I as a student was not real big on memorization, so those of you who had me before know that it's okay if when the test starts, you write the formula down. Like you have it in your head, and then as soon as I hand you the test, you write it down on the test. Anything that you need to remember, just put it on paper, and then you can just start the test. Yeah? All right, so let's continue in this section, all right? There's more to do here. So I want to start this new discussion by going back to the picture I had earlier, right? And what I did here, I'm going to color code this. We had some function here, f, and then we picked some point a. This point right here is the point a, f of a. And then we picked some other point, which I'll call x, or we called x, which is here. And then what we did was we slid that point over there. And so the slope of the tangent line was just the limit as we let that x slide on top of the a, which moved that point on top of the other one. And then what we did is we calculated this. And do y'all remember where this part of the formula came from? F of x minus f of a over x minus a. Do y'all remember what that came from or no? The what? The slope. That's rise over run. So basically what we were taking is, let me move this point over. Like if I were to draw a little triangle here, I did this on Zoom. We call this the rise. This is the run. So if you look at the rise is the difference in the y coordinates, and then the run is the difference in the x coordinates. So that's what we did, right? All right, so this right here is rise over run. All right, so I'm going to draw the same picture, okay? And this time, when I pick my points, I'm going to do it a little bit different. I'm still going to pick A, all right, this point here, and that will be the point A, f of A. And then the other point, you know how I called it x before? I'm not going to call it x. And you're going to sit there and go, why in the world are you doing this? We have a formula, let's stick with our formula. And I'll explain that later. Let me just do it first. So this point over here, I'm not going to call x. I'm going to call, well, it's that number plus something, right? So like think about it. If this was the number 3, this number is 3 plus something, maybe 3 plus 1, so it's 4. Or maybe it's, if that's 3, maybe that's 3.5, or maybe it's 7, right? It's bigger than a, right? So instead of writing x, I'm going to write this, a plus h. H is some number I don't know what it is. It's just, h is a positive number. So when I add it to a, I know I'm going to be to the right of a. Got it? I'm going to take that and plug that in and come out here, and I'll have a point up there, right? Can somebody tell me, well, first, what's the x coordinate of this point right here? A plus h. Good. Now, what's the y coordinate? Yeah, f of a plus h. F, and then you have to plug a plus h into the function, right? Just like over here, if you plug in a goes into the function, you get f of a. Here, if we take a plus h and plug it into the function, we get f of a plus h. Right? What I'm not saying is this. I'm not saying f of a plus h. Right? The a plus h goes into the function. It's not plugging a in and then adding h. Those are two different things. All right, so if I do it this way, and then I draw a right triangle like this, call that the rise and this the run, then I could have said that now that the slope of the tangent line is the limit. Okay, this is the part we have to understand. This is a little different than this one. If I want to move that point over, right? If I want to slide this point over, I'm not going to let x go to a, right? Because there's no x here. So what do I have to do to make that a start getting closer and closer to that a? That a plus h get closer and closer to that a. What has to happen to the h? It has to get smaller, doesn't it? Smaller and smaller and smaller and smaller. The smaller h's, the further to the left this moves, right? So what I'm going to do is instead of saying x goes to a, I'm going to take the limit and let h go to 0. If I let h go to 0, do you all agree that that point moves over? Right? As h gets smaller and smaller and smaller, that point starts to move across. Now I want that limit, and then I want the rise over run. So the rise is the difference of the y coordinates. So I'm going to take that y coordinate and subtract that y coordinate. And then on the bottom, the run is the difference of the x coordinate. So I'm going to take that x coordinate and subtract that one. So a plus h, take away a. Do y'all see that? I'm going to do one more thing. On the bottom, do you all see that these a's cancel? And all you have is h? This is our second definition for the slope of the tangent line. We now have two definitions. We have this one, and we have this one. Again, I understand if you're sitting there, go, why make a new definition if we had one that works, right? Like, why create more complexity for ourselves? And it's because of where we're headed, all right? Where we're headed, this formula over here, the second one, is actually going to be the one we use exclusively. All right. So if we can calculate this limit, right, we should be able to get a number. And then if we needed the equation, then we just do the same thing we did before. We have a point, we have a slope, we use the point-slope formula. So what do you say we do the problem we just did, but let's use that formula instead of instead of this formula, right? Let's do the problem off of the review. And then we're going to talk at the end about which way seemed easier to you, all right? So I'm not going to put the problem back up here. I'll just write it down. Here was the function. And the point I gave you was 1, 4, right? And we want to find the equation of the tangent line. Right? Find the equation of the tangent line at that point. All right, so we start by finding the slope of the tangent line. So the slope of the tangent line, using the second definition, is limit h goes to 0. All right, f of a plus h. Okay, what is a for us?
1.
Still 1, right? So I'm going to write f of 1 plus h. Let me write it down. F of 1 plus h minus f of 1 all over h. With me? So this is different than the last problem, right? I mean, the way that the other formula works. We have to figure out what this is, and we have to figure out what this is. Do you all agree that this is just 4? This is, what do you get when you plug 1 into the function? 4, we know that, right? So this is just 4. This is different, though, because this is saying, what do you get when you plug 1 plus h into that function, right? That means what happens when you take this x, right, and replace it with 1 plus h. That means you have to replace it here and here, right? So let me do that algebra. Let's see what happens. Okay, limit h goes to 0. All right, if I take that expression right here and I replace the x's here with 1 plus h, here's what I'll get. Let me write it down. 5 parentheses 1 plus h, close parentheses, plus 3 over, and then 1 plus h, and then plus 1. Y'all see it? Replace that x with 1 plus h, and I had to have it in parentheses because the 5 multiplies times that, right? So that's 5 times 1 plus h, and then plus 3, and then over x, which is 1 plus h, and then plus 1. Got that? Then I subtract from that f of 1, which we just said was 4, right? So minus 4. And then all of that over h. If you let h go to 0 right now, direct substitution, you're going to get 0 over 0. So now we need to do some algebra to try and clean this up. So let's see what kind of algebra we're going to need here. Limit h goes to 0. Let me do this. Let me distribute this through. Distribute the 5 through, so I get 5 plus 5h plus 3 over, on the bottom I'm going to do the 1 plus 1. So how about I write 2 plus h? And then I have minus 4, and then all over h. That's just me. I'm just cleaning things up a little bit, right? Any ideas now? What did we do last time? Common denominator. So let's do it again. Let's do this 4 over 1. So if I do 4 over 1 then I'm going to have to multiply. Oh yeah, let me put this 5 and 3 together. That's an 8, right? I can do that. Let me write it this way, 5h plus 8. I'll do it that way. And then over 2 plus h. And then minus 4 over 1. But now I'm going to multiply the top and bottom of this by what? To get a common denominator? 2 plus h. And then take that whole thing and divide by h. This is limit. H goes to 0. All right, let's see here. Let me see if I can do, well, I've already taken my time here, so I'll just continue taking my time. Okay, here's the first fraction. On the second fraction, distribute. So you get minus, the new fraction over here is 8 plus 4h, and then over 2 plus h, and then all on top of my common denominator of h. You'll see how I distributed the 4 through, right? But I'm saving the negative sign right now. I'm not using it yet. I'm going to use it on the next step. When I put these together, the negative will go through the top. All right, so that's where I am. So that equals, isn't this fun? You'll have that look on your face like, feels like a Monday in here to me. All right, we've got 5h plus 8, and then now minus 8 minus 4h. Minus 8 minus 4h, all over the common denominator. Do not forget, you have to put those together so you have a common denominator, and then all of that still over h. And do you all see that good things happen up on the top there? Let's see what's going to happen. 8's cancel, right? They're gone. And then you have 5h take away 4h, which is just h. Do you have any questions over any of this? What are y'all feeling is going to be the hard part here? Just remembering what to do, the formula, and then actually not making little mistakes, right? If you mess up one sign, it's over, right? How would you know that? I would know that I screwed up if I can never get this h to cancel, then something's wrong. I've done something wrong, all right? Things should at some point become nice. So that's where I am. The top here, those go together and give me the h. So I have h over 2 plus h, all over h, and these h's are going to cancel because I'm going to look at that as a fraction, and then I'm going to flip, same thing that I did before. Limit. Notice I'm writing the limit the whole time, right? I've not taken the limit, so I'm continuing to write it. So I flip the bottom fraction up. Now my h's cancel. Very important that we remember when those h's cancel.